Ever pondered about why objects move or stay still, or perhaps why it's challenging to push a stalled car, yet quite effortless to keep it rolling once it starts moving? Well, these are all part of the wonderful world of physics, specifically Newton's laws of motion. Imagine a soccer ball on a field. If no one kicks it, it won't move. But once kicked, it will keep moving until something slows it down. This, in essence, is Newton's first law, also known as the law of inertia. To break it down, if something is still, it will stay still until a force acts on it. Similarly, if something is moving, it will keep moving at the same speed and in the same direction unless a force acts on it. But what about that stalled car? This is where Newton's second law of motion comes in. It tells us that the force needed to move an object is equal to the mass of the object multiplied by its acceleration. Simply put, the heavier the object and the faster you want it to move, the more force you need to apply. Now imagine that you're ice skating and you push off from a wall. You move in one direction while your force pushes the wall in the opposite direction. This scenario illustrates Newton's third law, often referred to as action and reaction. It states that for every action there is an equal and opposite reaction. So, to recap, Newton's first law, the law of inertia, says that an object will keep doing what it's doing until a force acts upon it. Newton's second law tells us that the force needed to move an object equals its mass times its acceleration. And Newton's third law tells us that every action has an equal and opposite reaction. These laws, formulated hundreds of years ago, are still fundamental in understanding the world around us. From how planets orbit the sun to why we don't fly off a spinning merry-go-round, to the best way to score a goal in soccer, Newton's laws are in action. They are the building blocks of physics, enlightening us about the fascinating intricacies of motion. So next time you see a ball rolling across a field or feel the recoil of a fired gun, remember, it's all Newton's doing.